Actually, wait.
I've already used that out today.
That's the last. Oh, I didn't have eyes.
I got worried because I thought yours was all finished.
5, 4, 3, 2, 1. The derivative of arc sine, arc cosine, arc tangent, arc cosecant, arc secant, and arc cotangent. Now, I want you to remember that you learned the derivative of e to the x, which is, yeah, that was a pretty easy day, wasn't it?
Right.
And the derivative natural log of x is 1 over x. That's an easy day, isn't it? Okay, so you got to have one that's a little bit more challenging. And so the arc sine, that's that button on the calculator you press, you go second sine. So it's what produces the angle for you. You know what I'm talking about? Yeah, so if you do like sine inverse of 1/2, it'll pop up 30 degrees. So that's a function as well. It turns out that the derivative of arc sine, or maybe I should write it this, the derivative of sine inverse of x is equal to 1 over the square root of 1 minus x squared. Cosine is the same thing, it's just negative. The derivative of arctangent, or tangent inverse of x, is equal to 1 over 1 plus x squared. The derivative of arc cotangent, same thing, just negative. The derivative of arc secant, so the derivative of secant inverse of x is equal to 1 over x roots of x squared minus 1. And then the derivative of arc cosecant is the same thing, just negative.
Are we gonna have to know this for the derivative?
Amen, brother.
Amen. Amen.
Okay.
So, let's go. I don't care how you think about it. It's up to you. We have 6 problems to get through. I have f of x is equal to, if you'd rather write it as cosine inverse of e to the x, if that helps you to think of it that way, then go ahead. Anybody want to guess what rule we're going to use? Chain rule, very good. Way to go, Mika. The outside is cosine inverse of u, and the inside is e to the x. Jacob is groaning. I don't know why. I see the things he has to memorize all the time for AP Gov and for humanities and for all those other things, the Quizlets, all of it. So no big deal. We just got a few more. The derivative of e to the x is?
E to the x.
And isn't it nice that that's one of the things that you have to memorize? The derivative of arc cosine of u is negative 1 over the square root of 1 minus u squared.
Okay.
I multiply these together and I get f prime of x is equal to negative e to the x in the top and the bottom, the root of 1 minus what? E to the 2x. No big deal. That's it. Chain rule, tangent inverse of u, and 4 minus 2x. The derivative of 4 minus 2x? Negative 2. The derivative of arc tangent, can somebody remember without looking at it?
No, I think just
1 over 1 plus u squared, yep. As I multiply them, I'll get a negative 2 in the top, and in the bottom, I get a 1 plus 4 minus 2x, that quantity squared. Easy peasy. Flip it over.
No, this feels good.
Why don't you try number 3 on your own?
Okay. Okay.
See how you're super smart.
Right.
Mika wearing the cool Uggs today.
Yeah.
Just a reminder I need to do my Christmas shopping.
All right. I'm gonna have to. All right. It's a little too soon.
Give me some.
Give me a minute.
I feel bad for you guys. They're putting you through a 5-day week this week.
Test.
I'm just gonna not be here today. I just decided to carry on.
When? Shawty, we have 3.
She
Friday. Shawty, hey. How dare you?
Everybody got it set up?
Merry Christmas.
Look at how nice this is. You plug in the square root of x for u and you get, yeah, you get 1 over 2 roots of x times the root of 1 minus x. And if you'd like to multiply that x through, you can, but you don't have to. You get 2 over the root of x minus x squared.
How dare you speak Merry Christmas? Merry Christmas.
Someday you'll take that and you'll go to that.
Today is not that day.
And we do some of that in this class, but not that example. That's what happens. I mean, I get the advantage of seeing ahead of you guys. But for those of you who take Calculus 2 in college, that's where kids struggle, is they're going from this one to find that one. And guess what? Their teacher never showed them that one. See what I'm saying? So then they drop the class. They're like, oh, I didn't learn what I was supposed to. So those are things we want you to see. Number 4. Oh boy. How would you approach number 4? I'm looking for you to say 2 things. 2 things.
Product rule and the chain rule.
Product rule, chain rule, way to go.
Yes.
I have f of x is equal to x times the natural log of cotangent inverse of x. So does everybody see the product rule?
Yep.
Good. So f prime of x is, the derivative of x is 1 times the natural log of cotangent inverse of x. Plus x times, now I need the derivative of natural log. Good job. Man, you guys are smart. Natural log of u, cotangent inverse of x. The derivative of natural log of u?
1 over
1 over u. The derivative of cotangent inverse, who knows without looking?
I don't know.
Negative 1 over 1 plus x squared.
Good job. Negative 1 over 1 plus x squared.
I said I saw you on
Oh,
the
yeah.
sheets last night.
Yo.
I was in homework too.
Yeah, so it's a negative.
But
We have it down in our notes.
Oh, sorry, I was looking at code.
Logical.
Don't mind me.
Oh, so was I.
Waiting room.
We good?
Yeah.
Okay, so I'm gonna multiply these together and I get a negative 1 over cotangent inverse of x times 1 plus x squared. That's the derivative of natural log of cotangent inverse. And now I have to multiply that to the x. So there's really no algebraic simplifying in this process. We're just going to write the natural log of cotangent inverse of x. And then instead of plus, I'm going to write minus x over cotangent inverse of x times 1 plus x squared.
So how would this apply to something you'd actually you'd use in life?
Now,
I'm actually curious. I need motivation right now.
No.
Good
Nope.
talk.
Good talk.
Nope.
Architecture?
Architecture.
Nope.
No.
Nope. I'm trying to think. I mean, you could try to convince yourself that you're going to use the, arc tangent functions and arc sine functions like that in a physics application someday. There might be something in that line, I suppose, but not a lot. Again, the bigger idea is we are taking derivatives, right? And the big idea behind the derivative is really this. This is what we're going to get to in the real life. Is that, do you like money?
Yeah.
I don't, I'll take it.
So that, where the derivative is equal to 0, that's your maximum. So what are we going to maximize? We're going to maximize profit.
Okay, I'm all about that.
We're going to minimize cost. So when the derivative is equal to 0, that refers to our optimization. And that is where we run the best and most efficient ways possible.
Okay.
And we want to find those. So you are going to have a section right before a winter break where that's what you do. We're going to do optimization word problems so you can see the application of it. And we'll try to give you the most straightforward ones possible, but we'll try to give you a few that'll twist your brain a little bit. If you can do that, like if you can take math and apply it to the real world, I mean, you can make buco dollars. All right. What about this one?
Oh, so we're gonna have to do
Chain rule?
Right. Start up fresh.
Dima.
Sorry. I'm just a little lost. So what's the final answer?
What is the derivative of arc cosecant?
I'm gonna have to take a peek. One minus x.
-1 over u times the root of u squared minus 1. What is the derivative of e to the 3x plus 1? Want to do the chain rule? Remember, when you have e, you can just take the derivative of the exponent, which is 3, and multiply it by the function. Does everybody agree when I multiply these together that this goes to the numerator? Okay? And so we got -3e to the 3x plus 1. We're going to have to show a little bit more academic toughness here, I think. And we're going to take this and we're going to drop it down in for the u's. And hopefully you should see something that makes you happy.
I don't think I see anything that makes me happy when I
It
see
makes me feel
some ease.
empty. Very debilitating.
Ava, what do you notice?
Cancel.
Thank you, Ty. The e to the 3x plus 1s, they do go away, don't they?
Okay.
So this is an example where you do get some reduction.
Yay.
I have a -3 in the top over the square root of, and let's see here. If I take e to the 3x plus 1 and square it, what do I do to the exponents? Multiply. So you get e to the 6x plus 2. I have a -1. And our last example. Look at that, you guys get like 15 minutes to work today. Somebody brought treats and put them on my desk. Did I miss somebody's birthday this weekend? Maybe it's probably one of my flex kids, I think, that they brought. I'm starting to really like my flex group. They're doing a good job. I had to reel them in a little bit. First they're like jumping on tables and throwing
Was it
things.
Danny's brother?
He was just on his phone.
That one blonde kid with like really long.
He came back the other day. He was like, "Hey, Gens, did you notice something?" I'm like, what? He's like, "I got my hair cut." I'm like, "No, you didn't." It's like instead of his hair here, his hair is down here. He had about 3 days, and after 3 days, he still has to go like. Oh my gosh. Oh. People think I'm jealous. Yeah, I'm jealous. So jealous.
So what's the huge box?
Yeah, I don't know. I just decided to go big. I got arctangent of u. I get x minus the root of 1 plus x root of x squared. What's the derivative of arctangent? 1 over 1 plus u squared. Nice job, Miss Murray. The next one, the derivative of x is 1 minus. Now I need the derivative of the root of 1 plus x squared.
Is that another chain?
That's a chain rule.
Oh, okay, okay.
Okay, that's fine.
We got this.
Jacob, Jacob, if this is tough to say you've been covering life, you've had a really good life. The derivative of the root of u? 1 over 2 roots of u. The derivative of 1 plus x squared?
2x.
2x. When I multiply those together, the 2 and the 1/2 will cancel, and I will get x over the root of 1 plus x squared. And so there's nothing special about writing this. All we can do is just take this and dump it right in for u. And so we get 1 over 1 plus parentheses x minus the root of 1 plus x squared, that quantity squared, times the quantity 1 minus x over the root of 1 plus x squared.
It's just a lot for a Monday.
It is. There's no doubt. It's ridiculous. We're used to having like every other Monday off, so
Yeah. Right.
I get it.
Let's get out of here.
Well, that's it. So I just want you to know that for your test, your driver's test, I already have your study guide ready to go. And we're going to look at what you'll be expected to do for that test so you can be fully prepared. I know you all want good grades. Again, I do think that for some people, they say that second quarter is kind of the hardest quarter for them for calculus. So you guys are in the thick of it. I'm not going to say that, but I'd say that, you know, for as far as the whole quarter is concerned, you know, we're doing some, you know, some things that are challenging here. Okay. But turn to the second page. And you can see question number 4. Question number 4 will be your deriver's license. Okay? So I'm expecting you to know the derivative of sine, which is? Cosine, which is? Negative sine. Tangent? Secant squared. Cosecant? Negative cosecant, cotangent. Secant? Secant tangent. Cotangent?
Negative cosecant.
Negative cosecant squared. E to the x.
E to the x.
E to the x. Natural log of x.
1 over x.
1 over x. Sine of x, or sine inverse.
1 over the root of 1 minus x squared.
Yep, 1 over the root of 1 minus x squared. Arctangent.
1 over 1 plus x squared.
1 over 1 plus x squared. Arcsecant. 1 over x roots of x squared minus 1. How about the power rule? X to the n.
Is it x to the
N times x to the and minus 1. That's our power rule, right? That was that day. How about the product rule? Yep, f prime g plus g prime f. How about the quotient rule? Yep, f prime g minus g prime f over g squared. And then finally the chain rule. F of g of x.
G prime of
Yeah, so I know that you guys are able to write the boxes, but I want you to see that if you have h of x is equal to f of g of x, then h prime of x is equal to the derivative of the inside times the derivative of the outside with the inside left alone. Okay. And that's that. I believe that is it 17 derivatives? 12, 13, 14, it's 15 derivatives for your driver's license.
And they have to all be right.
You must have 100% to get your driver's license. If you do not pass it, you can retake that portion only to get your driver's license. But I'd love to be able to submit the driver's license to everybody.
Let's try.
Can we customize the color of our?
It'd be nice if somebody made a Quizlet for.
No, I'm gonna choose.
Okay.
Blue, probably.
That's red.
I think we should